All right, it's finally there. You guys beat me. Yep, I'll find it. 257. You guys are messing with me.
And we have between sections.
And then if you back up a couple more pages to 255, it's where we really need to start. And they were talking about the convert statement. Convert is a function, and just like if we create a function or a method when we're writing a program, you know, different programming languages call those different chunks of code different things: a function, a subroutine, a module, a subprogram, a method, whatever it's being called in our language. We know that we pass data as parameter values into a function or a method or a module using parentheses. And our functions that are defined by SQL Server are the same. They work the same way. So we use the function by calling it by name and then passing in data as parameters for the function to do its job. So this one on page 255 is an example of a select statement that uses the convert function. In the convert function, we're converting the invoice date, and we're converting several different dates here. Yes, sir? Oh, I need to set, would you like me to share my screen? You guys are so big. Thank you, sir. How's that? It's not doing anything, huh? Yell out, it's okay. It's not doing anything. So I want to try this convert function. So let's see what it does. It's kind of a long one. So I'm going to see if I can log on here. And I'm going to create a new query. And I want to use the AP database. Let's see, or maybe examples. Let's try it. I'll just throw something out there.
Thank you.
Better. Now, we want to start with our select statement. And as we select data from our tables, we're going to run some information through this convert function. So we want to use the convert function as part of our select statement. And if you look at the IntelliSense that pops up as soon as you type convert, you see that it wants specific parameters: the target type, the expression, and the date style. So we're saying that our target type is a varchar, or a variable number of characters. The date that we want is invoice date. And when that is returned, we want to call it varchar date. So it's kind of like using a method or a function in our code, in our programming code, where we're saying that we want to set a value equal to the return value from a function. Our convert function is going to return a value, and we're going to call that value varchar date. Now I'm going to try to keep going here. On the next line, we want to do another convert. And this time, again, we're going to use the same data and the same type, but we're going to use a different date style 1. And we're going to call this varchar date _1. So when we're using programming languages, we might have several different keywords that we can use for dates. When we're using dates in SQL, if we want to format them, we can use these numeric date styles. We'll go look at it. _1, And then this next one is going to use style 107, so it'll be named underscore 107. And while you're looking, here are the different common styles they say. 0 or 100 outputs like a 3-letter month, 2-day date, 4-character year. So we can see all these different styles. Okay, so after our 107, we want to do another one, and this time sets the date style, the style that we want it to be output as. Yeah, there's obviously hundreds of them. That's why our textbook just lists the real common ones. Now we're going to format the invoice total. So our invoice total is a numeric data, not necessarily a date, right? But we're going to use a formatting code, number 1, for that. So let's run this, and we can see all these different formats from our invoices table. Hopefully you can see it. I'm going to try to run that. Maybe it would like AP better. Yep. So use the AP database. Now what we end up with is all of these different date formats. So notice the different styles. When we put that comma 1, we get the 12/8/15 with slashes, so a real short date. And it's an American style, right, with the year at the end. For the underscore 107, or the 107 numeric code, we get a more friendly date. And for our varchar total, notice the number 1 formatting put commas in. So it just added the commas every 3 digits to our numeric output. So yeah, there are lots and lots of different formatting codes that we can use. In your textbook, they list several. So the common styles for converting date are times, and you will need to use some of these in your assignment, either for chapter 8 or 9. I'm not sure which one, but I know that there is some date formatting that you'll have to use. So we can use these codes with this convert keyword, and all we're doing is saying, take this data, convert it to a variable number of characters using this formatting. So we've got to kind of get it to whatever format we like. So that's the basic convert keyword. The try convert is kind of like a try catch when we're programming. So when we are coding, we know that a try catch says try to do this operation, like convert something to a number. If you can't do it, then catch the error for me. Well, that's kind of what a try convert is. It's going to try to see if it can do that conversion. In the example that they show us, we're going to set up a column that's kind of an extra column, and that column will try to convert an invalid value. So we'll see how it works. This one is a big one, so I'm going to copy this code and create a new query and paste it. Now, when I paste that, I want to change each of these converts to try underscore convert. So you could just copy that if you like and paste it before each convert keyword. And then let's add one more column here at the end. I'm going to put a comma, and the last one we want to try convert we're just going to put a date in, and this is an invalid date because there was no February 29th in 2015. It was not a leap year. So we're going to select that as invalid date. And what we're wanting to see here is that we're going to get a null value there instead of a red error message saying that it couldn't run our query. Let's try it. Looks good. So I have this invalid date that gets turned null at the end of each row because we asked for it in each row. Now take the try off and make it just be a convert. And we should see that red error message because we had an error, right? It couldn't convert that invalid date. So the try convert will allow execution to continue. Just use a null value. So those are our two big things that were in Chapter 8, besides all of the data types that you guys documented. So let's look at your OneNote notes. And I would like to add a new tab for Chapter 8.
So we be try convert, it doesn't pop up anything in the messages where to know that there was an issue.
Right, it just gives you a null value.
So you got to remember to pay attention to that.
If that matters. Depending on what you're doing, yeah.
Not depending what you're doing, you could building.
Yep, okay, so for your Chapter 8 notes, we have convert and convert. Converts data to a selected display format. How about we describe it that way? And I would like to, let me find my numbers here since I got everything hidden. I'm going to pin my toolbar so that I can see it and set up some numbers. So for this convert, see the data conversion numbers for exact formats. And you can copy that from your textbook if you like, or whatever you want to put in there. But whatever you're going to have to do to remind yourself that that comma 1, comma 47, or whatever means a different type of date. You can copy some code in from your SQL query. Here's a good one. And then we saw that try convert converts invalid data to nulls instead of canceling. Otherwise, it does the same exact thing. Now, the rest of your notes for Chapter 8 should be your mind map, right? So I would go copy that from wherever you guys saved it, or go download it from Canvas if you don't have a good copy of it, and paste that into your notes because you've already documented all those different data types on that mind map. So you want to add that in here to your OneNote notes. Sure. That one?
Yes.
Yeah, no problem.
So is it trying specifically on that column? Like it appends that specific date to every.
Anytime we do a select statement, we return rows, right? And our list of columns is what rows what we want in each row. So, yep. Nope. It just looks weird, doesn't it? But yep, that's what it does. So, Every row we get, we'll have that. Silly Outlook. Okay, so awesome. When we are working with some unusual data types, there are some other data conversion functions that are available, like str to convert to a string, char to convert to a character data type from an integer, ASCII to convert to an ASCII value, nchar to convert to a Unicode value, Unicode to convert to a Unicode value, just different types. So here we have an example of using the str function for a string, where we've specified like how many digits and how many decimal places we want to be included in our string. So notice that we have a lot of formatting capabilities, and that's because SQL was designed as a query language, and so its purpose is to try to meet all the needs that we could have. So there's some really, really intense formatting that's available. Now, whenever we're working with C# or Java or Python, some of those other programming languages, we've seen that we can send a control code or a control character to make the output go to a new line or move over a tab character. We can do that same thing with our SQL queries. We can send a char value of 9 as a tab, a char value of 10 is a line feed, and a char value of 13 is a carriage return. So our \new line, \n would be the line feed. So we could send a char 10.
On that str upload there,
Uh-huh.
what's the 7 for?
You'll have to look at the string function up here. What does it say? Given length and number of digits to the right of the decimal place. Probably.
I used that as
Preloaded. Did you try it? Good.
Well, we had to output like just month and date.
Uh-huh.
I used the original output and it just said, but only the 6 spaces.
Awesome.
If that's okay.
Used it that way. That'll work. Lots of ways to do it. Do what?
Align the decimal point.
You-
I hate it when I see a list of dollars where the decimal point floats all over.
Oh, that you need to write justify. And that's why for numbers, we always want to write justify so our decimal place gets lined up as long as we have 2 decimal places. They're just using this one as an example because, yeah, you would normally want 2 decimal places. So you could change that.
That one, the 7, not exactly working. It'd be better to have the 5 for that.
Well, no, there aren't 7 digits to output if you only use 1 decimal place.
Well,
If there were, it would.
I mean, on the 7,
Doesn't matter.
they're only outputting 5.
Right, but if there were more, it would output more.
Where does it count the dot as a character?
Don't think so.
Even then, it's only 6.
That's why it threw me.
But it does that because of the 1 decimal. It cuts it
So
off
you
right
can
there.
put 7, it'll round up until it needs to
The 1 decimal.
Yeah, to 1 decimal if need be.
To 1 decimal.
If they put 3, it would have done 4.6.
If they'd have done 3. Oh, yeah, let's try it. I'm going to copy that. Or at least the part of it that I can. I'm going to take it to SQL Management Studio. Let's see it. We'll just create a new query. So I'm going to use AP. It won't matter because we're just going to select this string. So let's select this string. Can we do like that? Yep. We didn't even need anything else to try it. So with the 7, 1, we're getting the 1, 2, 3, 4.6. So let's try 7.3. I don't know. Let's just try it. 1, 2, 3, 4, 5, 6, 7. So it couldn't fit 3 decimal places in those 7 output spaces, right? So it only gave us 2. What if we say 8 here? Can we get 3 then? Can we get 3? So yes, that number is the size of your total output, including the dot.
Why is it being up there? That's 60.
And round it up.
And it is rounding, which is really interesting because we're used to having to do so much to get those kinds of things to happen.
How would you do that?
Yes. With the commas, you'd have to do that convert. And we're going to say what it's going to be, varchar. And we want to convert this string. And then what was it, 1?
And you can have that display those line numbers.
The what?
The line numbers.
Over here in the output? Or,
Well, no, just
well, let's just go see. We'll just ask Google. Okay, Google says, in the options dialog box on the left side pane, expand the text editor and then expand transact SQL. Okay, let's do that. So up here, find options under tools. And then over here on the left, we want to find text editor. And then expand transact SQL. And then click on general. And we want to check line numbers. Does that work? Oh, good job. Yay. Okay, we needed that. Long time ago. Yay. Sure. Go to Tools, Options, then expand Text Editor, and Transact SQL, and then click on General under Transact SQL, and check that line numbers. Yay.
no.
Yeah, I would love to. Okay.
That's a lot easier when you have a problem. And it tells you line 8.
So we were trying to convert this to put the commas in before we got our line numbers, which I think is great. But this didn't work. So I wrapped the string function within the convert function, and that didn't work. I don't see anything different. I don't get any commas. Can you see why that might be? Remember, this convert function we want it to apply this numeric formatter to our parameter. Is that parameter numeric? No, we just made it a string. So can we reverse the order and nope, we need to put our string function outside of our convert function, right? So convert it first, maybe. Ah, no different. You're just gonna have to fight with it. Seems like that should do it. So let's see if we get rid of our string, do some troubleshooting here. We're not getting that numeric formatting. Do we have to say as? Nope.
That just changes the.
Shouldn't matter. Yeah. So I don't know why it won't give us that. Maybe it just has to be a certain data type to start with. Nope, it's just not doing them. So we'll fiddle with that later because I don't want to waste a bunch of time on it. But if it gets to be a thing, I'm sure that we've just got to wrap things in a certain order. So we can play with our SQL and do data manipulation, just almost like we're working with a programming language, because we kind of are. So let's look at chapter 9, because I don't want to get us behind on things. And in our OneNote notebook, let's create a new tab for chapter 9. So chapter 9 is going to talk about all the various functions that are available. So I think if we just list a bunch of them in our notes, then we can try some examples. So what do we have first of all? Kind of like our data types. So our functions give us the ability to manipulate our information and change the formatting and all of those kinds of things, convert from one data type to another. So we already saw some of those functions. But we have some different types. We have string functions. These are the kind of string functions that we have, and they should be very similar to you because they're just really a lot like the string functions that you've seen in different programming languages, right? So we can determine the length of this string, trim spaces off the left, trim spaces off the right, get a certain number of characters from the left or from the right, pull some substring information out of the middle, replace some letters. So all of these different string functions are available to us. So we'll just call those standard string functions. We want to try some, but for now we'll just put it in our notes. Now we also have what's called a cast function. And this is sort of a string function, but I'm going to put it on its own. And this function allows us to sort a string that contains numbers. So it's kind of like the difference in array processing between C# and Python, if those are languages you're aware of. We can make it to where SQL will sort a bunch of strings without griping at us and without sorting it in alphabetical order. We want it sorted in numeric order. So we can use that cast function for that. Next, we have numeric functions. And again, they're kind of like our standard string functions. Let me bring up the list of those and show you. So you can try them. Again, these are pretty similar. We've seen a lot of them in our different programming languages. We can round. We can check to validate something as is numeric. We can get an absolute value, do a ceiling, floor. We could square a number, do a square root, get a random number. So we can do all of these different numeric things in our SQL code. So that could be part of our select statement, but we'll see that we can also make it some additional programming. Now, one thing that we'll try, they're going to show us how to search for approximate real numbers. And real numbers are those numbers that contain decimal places, and we've been told since the beginning of programming time, we can't do an if statement with decimal places because we'll never ever get an equal value, right? We have to always be careful. We have to use greater than or less than when we're doing things like that, because otherwise we'll never get an equality value. Well, SQL is going to let us try to search for numbers that are approximate. So it gives us some additional searching capabilities. Then, of course, we're going to have date time functions. And we'll be able to look at some examples of that. But one thing that's nice is we can search for things by date and time. So there's some special functionality available to us for that. Okay, and then we have some special keywords. IIF. IIF is like a ternary if. And if you remember what a ternary if is, or if you've seen one, it's where we have if this condition, and then we have two actions after the if statement. The action to take if the if is true, the action to take if the if is false. Just a single command for each. The IIF gives us that capability in SQL. And then there's another one called choose, which lets us kind of pick from a list. We'll look at some of these in a little bit more example when we get to it. All right, so those are some good ones that we're going to try. So let's start out with our string functions. Let's just practice a few. So I'm going to be on page 265 is where they have the list, and they have an example here. And in our example, we're going to select a lot of vendor information from our vendor, and we're going to format that output a little bit. But we're going to be selecting based on part of the phone number instead of the whole phone number. So we'll use our substring in that where clause. So I'm going to open a new query window, and I want to use AP. I can. And I want to select. So we're going to get our vendor name, vendor contact, L name, so their last name, plus, we're going to do a little concatenation here. We want to add a comma. Then we're going to use the left function. So we want to use the left function on the vendor contact first name. And we just want to pull that initial, that first character out of their first name. So this will display as last name, comma, first initial. And we're going to add a dot to the end of it and call that contact name. Now some additional columns in our query. We want to right justify the vendor phone number, and we only want to use 8 spaces for our column. And we want to call that phone. All of this should be selected from our vendors table. And in our where clause, we're going to specify a substring. So on our vendor phone, we want 559. Hang on. And we want to order it by vendor name. So is that going to start at the second digit of the vendor phone number or the third digit of the vendor phone number? What do you think?
I feel like this is going to go from, you're doing a substring from these somehow with some form of item.
Well, let's see if we can figure it out. So we're saying substring starting at position 2 for 3 characters should be equal 559. So let's run this first.
AP semi.
Do it.
They bought it. You didn't put a summary after 8 weeks to get it started.
It did take it, yeah. And it might just because I'd been using it before. So I'd like to look at all our vendors to be sure about that phone number. So let's open a new query and let's select star from vendors. So when they say they want to start at position 2, looks like they're grabbing the area code, huh? And the position 1 would be that opening parenthesis. So we want to skip it. So we are counting the phone number starting at 1. So the parenthesis is position 1. Are you giving me a gross look? Am I saying it wrong? Justin's over there giving me the evil eye. So yeah, we're starting at position 2 for 3 characters. So the substring is super handy because looking at our phone number then, we can't tell because we chopped off our phone number. We said we only wanted 8 characters. Let's make it longer on our output so that we can be sure. I'll go up to 13 to account for those parentheses. Oh, 14. One more, can't count today. So now I see the wrong query. There it is. So sure enough, all we have in our results set here are phone numbers with area codes in 559. By setting our size value for that vendor phone, we were able to eliminate that area code completely from our output because we don't need it, because it's redundant, right? Because we're only looking at phone numbers that are in area code 559. So the substring is really, really valuable. Get used to it because we don't get a lot of opportunities to do a lot of string manipulation sometimes in our program coding classes, and the substring is really, really handy. So at position 2 for 3 characters.
So we just took away the substring, would it pull out all the numbers? And then
Like if we just didn't have it at all? Let's try.
or at least.
I have to get rid of the whole where.
Yeah.
So what do you want to try? Just like the,
He wants to get rid of the 2, 3.
oh, I know it.
Or just like get rid of the 559 and stuff, so where it would just pull out everything, would pull out all the numbers, including something without 559.
Mm-hmm. But we could probably use some other keyword like matches or something like that. Some of those ones that you guys saw at the very beginning of the book, because that would give us a valid query also. But if we did matches, then we could also pull out phone numbers that had 559 accidentally someplace else in the number. So by doing it with the substring, we're limiting it to be exactly that area code, depending on the pattern we use. So lots of ways to do it, for sure.
They lumps the positions of the phone numbers by the section of the thing that dashes. Is that what they do?
Right, that's how you format phone numbers. Mhm. You always have the first 3 is the area code, the next 3 is the exchange, and the last 4 is the local phone number. So it's always split that way. Okay, so let's look at how to take a string and sort using it. So we've got this little string sample here we're going to try. I'm going to open a new query. For this one, looks like they're using a little table here that we don't have. So let's just look at their results. It's fun to make a table, but we don't want to right now. So here they're saying they have this table called string sample, and it has just 3 columns, ID, name, and alt ID. And if you look, the ID appears to be numeric, the alt ID is a string. So if we order by casting, the ID is integer, we get a nice numeric sort. We can pull, again, left and right information out of their names. for more string samples. So just lots of great samples here. Let you look at that. So what about our numeric functions? Page 271. Let me get to it.
And this other example that we did with string formatting,
Do what?
the one that we did with the right left was considered string formatting.
That's string formatting. Now, this is a really long one, so we're going to just look at it. Here's a select statement that formats real numbers. So we're using a sample table that we don't have, that they've just created here, to show us some input and some output. Basically, I think you guys have gotten a lot of it figured out, where you're going to have your length and then your number of decimal places when we're formatting numbers working with SQL Server. So we have a lot of different options here to format our real numbers. Our date-time formatting is really something that we do more than anything else, right? Because we oftentimes have things that are set up in dates, and we do a lot of date-time formatting. So in our date functions, we can get the date. So if we wanted to run a select statement where we get the current date and output that as one of our columns, we could. We could get the universal time, date, and time. The system clock. We can get our date time offset, which is our difference from UTC time. Day, month, year, where we can separate dates into different parts. We can get a specific part of the date, also using date name and date part functions. But what are really nice is there are some date manipulation functions. So date add allows us to take dates and add days to them or years to them or whatever. Date diff allows us to use multiple dates and ask what the difference is between those dates. So lots of different great things that we can do.
So I've got a question on that. Does it play well, like when we do, because I noticed that you, in the C# we're doing stuff with the date time. Does it play well with those date conversions from other languages?
And it's just that you have to always be aware that a date time type data field is going to have all of that information. And so you have to specify your formatting appropriately, depending on what you want. So sometimes we're surprised because we're not thinking of date and time as being down to the millionth of a second. But it is always going to be if we get the system date or system time anymore. There might be some old methods that you could use that wouldn't return that. But you pretty much want to have that level of accuracy with your date time functions.
Yeah, when you're working with equipment that needs to be synchronized.
Yeah, like Y2K, shut down the world because of a nuclear disaster. Date time functions.
When I was in the military, we synchronized cryptographic equipment. And we had to be within a second of the person on the other side. So we use universal time code. Down to the second.
Always scary when you're to that level. Let's try it. I'm going to select get date. There's our date time. So again, very long format because that's going to be our most accurate. Now, if I want to get UTC date, oops, I got to run it, not just press enter.
Oh, so that just goes to the current.
So that's our current universal time, and we're, 7 hours off from it. We have sys date time. Let's see how different that is. A little bit longer of milliseconds there, maybe. Gets a little bit more precise. Now I could set, do what?
If you put them in the same query, you can get them
together.
and see the difference. Now, if I want to just get the month part of that date, I'm going to wrap that sysDateTime call, function call, within a month function call. If I want to get the date part, let's do a little bit more of a query here. I can see, oh, I just want the date part of today's date using getDate. Oops, I need another argument. Let's see, which part do I want? Oh, I would like the year. And so that way I can pull out the month, I can pull out the year. And those are using the current date. We could run these same date part functions or month function or year function on a date that's in our database to get that same extraction to occur. But in order for that to occur, the database has to be set that this is a date time data field. We can't be saving dates and times as strings or things like that so that we can control them. Things won't work right.
So that you use like if your update log, or date,
Everything. So you want everything. If you're working for a company that's processing sales of any kind, you have to have an exact time that that person ran that debit card. Yeah. So you're always going to be looking for that exact long date time. Now, what's EO month? If I say, well, let's see, I want to know what the end of the month is for today's date. Let's see if it will let me do it that way. Oh, it says the end of the month of this month is 10/31. And I need that often too when we're processing and doing accounting type things where we need to know what the last day of the month is. So that can be a due date and things like that. Payroll, yeah, paying things. Now another one that we can use is, let's try the date from parts. This one I can actually, we can build our own date. And that's just going to format that as a valid date time variable then for us.
yeah, one of those that goes all the way down the thing of how much you put in.
It should be. So let's see if we can add more. We'll put in, say it's 8 a.m. Nope, got mad at me. 3 arguments for that one. So we'd have to find another one that did seconds.
All right.
Time from parts, probably.
Oh, I see what you're saying. That is the date specific.
Since it's a date. So we have a lot of capabilities with our dates, and we really do use dates often. Let's look at one where we can pull out, what do they want here? This date name is another function we can use. So for date name, I could say, getting today's date, what is the name of the day? And it would say, oh, the name of the day is 16. Not a very good name. What about month? Month has more of a name, doesn't it? I run it. Oh, October. That's better. So now it's giving us some reasonable information back. So what if I have today's date and I want to add a few months to it? Date, add. I've got get date to give me today's date. And I would like to add 90 days. So day 90. So when we use our date add function, we're going to specify what kind of day item we want to add, a day, month, year, hour, minute, second. what amount we want to add, and then third, what date we want as our starting point. So if I run this one, I'll see that 90 days from today is January 14th with my date add. Now, date diff is really helpful. We use this a lot. So I'll add one more that I want to know what the difference is, the number of days between 2017, 10/16, so that would be last year, and our current date. So how many days difference is there between those two dates? And there's 365 days. So we can use the date diff and all of our different date functions. You guys have actually done date searches before, where we're searching using a where clause with a date. So here they just have some queries to show you that these just ignore the time part. So that's actually kind of more handy, right? Because some of our programming languages make us get really specific if we want specific parts of the date. Where SQL Server is like, if you just put the date part, that's the part I'm going to use, and I won't worry about the time in my where clause. Now this select statement here in the middle searches for month, day, and year components. We could use the cast function to get rid of the time if we wanted to use it in a search if we needed to for whatever reason. Or we could use the convert function to eliminate the time. So all of these will work, and it's just like some of the other stuff that you've seen, lots and lots of ways to, as they say, skin a cat, right? So you could get it done however you want it, and that'll work.
So on that date, I guess it was
And see what it does? I'm sure everybody else would like to know too.
So I was wondering how it doesn't like it because we have to specify what part you want, I guess. Because they have other parameters.
I think it did. Now select statements when you're working with the time, same thing. If you only have time value specified in your where clause, the server's just going to ignore the date part and everything will work. But you could use some casting and converting if you want to format that yourself to get really specific about that search. So it's kind of up to you. Now the case function is one last important one. There are some other functions that are presented in your textbook. We're not going to look at each of those. But the case function is a select case statement, like we would use in a programming language. So here we can say that we want to select a certain thing, and based on a function or a value, we want to output something specific. So this middle select statement, take a look at it. We select invoice number, terms ID, and then we have a case statement on our terms ID. Let's put that one in. It's not that bad. We can do it. New query. I'm going to use AP even though I'm probably already using it. And for this one, I wanted to select invoice number and terms ID. And then after the terms ID, we have another comma, but our next column result is going to be based on the output of a case statement. Our case statement is going to look at the terms ID column. When the terms ID is 1, we're going to output net due 10 days. When the terms ID value is 2, we're going to output net due 20 days. When the terms ID column is 3, we're going to output net due 30 days. Now 4 goes to 60 days, of course, obviously. And then when it's 5, we've got 90 days. So our poor programmers have to keep doing this all the time because some genius decided to not make that terms ID be relevant. But we can handle it. Now, when our case statement is done, we have to have the keyword and. We're going to call that column that we're going to be creating here terms. And we wanted to select all of this from our invoices table. So really nice, we can output exactly what we want based on the data that's in our given table. So that means that it's really easy to format things in a nice, friendly way for users. Just a little bit more work for us, but not too bad. Tell me, what does it do? Well, look at it, tell me what it does.
It looks like a switch.
Yeah, it is. You're so right. What's it doing, guys? Tell them.
It totally builds that third column.
That's a good way to put it.
Wait, where's the statement? Oh, there it is.
Do you see it?
So looking at the terms ID column, whenever the terms ID is 1, then it prints out it's due in 10 days. And then if terms ID is 2, then it prints out it's due in 20 days, so on.
Very good. So super handy, we can do a select case statement in our SQL statement.
Oh, well, that's good. One thing I like about SQL is that the terms on it are very straightforward.
Yeah, they are. And it doesn't really try to ever be tricky or anything on you. It's just pretty much, here's what it is. And as long as you're looking at your data to make sure you've got the right results. Well, I think that there are a few more functions in your chapter that you want to kind of review, but we've looked at the most widely used ones, and you should have some good examples. So decide whether you want to copy your code into your OneNote notebook or save your SQL files. But go ahead and update your notes, and then let's use the rest of our time to get the assignments done so that we're ready on Thursday to start with database design. So even though this chapter 9.1 isn't due until Tuesday, you might want to just get it out of the way. Get them both done. And then you can do, yeah, one due tonight. I figure you guys are already done with it. So let me know if you have any questions or problems. I'm going to end our Zoom session thingy. What's that? You what?